OK, cool. Welcome to the talk. My name is Kevin Galligan. I'm president of Touchlab. We learned recently that introducing yourself in a talk is apparently a trashy thing to do, but I'm doing it anyway. That's sort of an inside joke. The Touchlab is we're a mostly dev shop. We've been around since 2010. Android only until 2016 or so. We make apps and hardware things. We do a lot of community stuff, which includes the big Android meetup in New York and Droidcon NYC, which means I spend a lot of time talking to mobile developers about mobile development. So I'm going to set the Wayback Machine to 2016, and we're going to talk about why I'm here talking about this to some degree. So there was this thing called DOPL, which is an architectural framework based on J2OBJC. J2OBJC takes Java, makes Objective-C, and also has a JRE for runtime stuff and some other libs. It's built by Google, used by Google on lots of stuff. We took the Android open source framework, architectural stuff, which includes the context and SQLite database and threading and shared preferences, and then we made tooling and other stuff to support building things, and then had a whole bunch of libraries you're used to retrofit RX Java, Room, architecture components, yada yada, for the purpose of building your Android app with your Android-specific UI stuff and your Android-specific native stuff, and then having a bunch of architectural stuff that you could then easily share to iOS, call it from Swift, and do all the equivalent things on iOS. And it works great, and we did it with a bunch of clients, and this was the collective response from the community. Nobody cared. It's essentially, I would argue, a really good example of a high-performing combustion engine in the time of electrics. So I like it when people announce things at conferences, and I'm here to tell you that my business is no longer in the DOPL J2OBJC business. We're officially pulling all that stuff down, and it's Kotlin Multiplatform from here on in, at least as far as our multi-platform efforts are concerned. And this picture I thought was great. So goodbye, DOPL. This tweet came out as I was preparing these slides, so I'm going to tell you what went wrong. And the tech was actually pretty great. I mean, nobody liked the idea of Java going to Objective-C. That sounded revolting, but it worked really well. But perception was really bad. Perception we got really wrong. And it was right around the time that Kotlin was officially supported by Google, that nobody wanted to hear about a Java thing for sure, even if it was practical, right? And as bad as the Android community response, iOS people lost their minds. Absolutely just hard pass. Often polite, sometimes not. So we talked to a lot of big orgs, pitching them on this, and we learned a lot about you have to appeal to like management and to the development teams, and if you don't really kind of get both on the hook, it's not going to go well for you. Also, outreach to iOS developers is going to be very important for Kotlin multi-platform adoption, and it's something that I think we as a community have to think about if this is what you're interested in doing. So, also, fundamentally, I think the problem was there was this J2OBJC thing is kind of focused on now, but it's really just focused on native mobile and kind of older languages, quote unquote. You know, native and web are going to be blurring lines. WebAssembly is coming. There are hardware things coming, new platforms, modern language features. So it wasn't a very inspiring pitch, which doesn't really get people's attention. So if you happen to be an org that was remotely touching this stuff, and this is probably more for people looking at videos, I don't think anyone here was using it, reach out, get the repos. We're not going to leave them out there as a ghost town. They're already pulled down or in the process of. Happy to hand them out, but we're not going to have a dead project out in the wild. Two things. Number one, spending a couple years making Android things work on iOS. I have a ton of experience doing that, which was beneficial for this whole Kotlin multi-platform experience. And two, in that process, I essentially, although I'm technically the president, took myself out of day-to-day, and all I really do is like learn new stuff, poke around, write libraries, travel and speak, write blog posts. I am the chief hacking officer. Hopefully, the focus will result in something meaningful to the contributions to the community. I mean, it's not all me playing with toys. I have to figure out a revenue stream for the business too, but getting a little breathing room as this stuff develops. So yeah, our future is all Kotlin, and we're looking forward to it. So, shared architecture. So the phrase means to me like tested logic, but also storage, networking, threading, all that kind of stuff, the guts of your app, not just business logic, which is often kind of lost in these discussions about sharing code. And it really kind of, the talk is about mobile, but it's about, in my mind, eventually mobile and web. Everything in the future is mobile, regardless of what 5G does, and you should be architecting according to mobile. There are, features of native mobile and web have been like blurring the lines kind of since the beginning, and that's just going to continue as time goes on. Shared logic will make that easier to manage, but definitely not the UI, at least not yet, right? So shared UI tends to be rough. And the native platforms that are out there, they're not actively trying to damage the other platforms, but they're only concerned about their UX. And they don't give a shit about your shared UI solution. So they're going to change any way they see fit. Either you have one language, for this unholy mess of things. So React Native, earmuffs if you're a fan, or if you remember Java AWT, or you have a surrogate UI, right, which is like a Flutter, an HTML5, a Java Swing, work, not really the best all the time. But shared logic is the history of computing, right? And I love using this slide because people see write once, run anywhere, and they kind of think failure. But Java as a vehicle of shared logic, the amount of value to the world of computing that has delivered or at least catalyzed is kind of hard to measure, right? So what was a failure? Shared UI is hard and hasn't been traditionally done well. I mean, of course, shared UI has been done exceptionally well in some contexts, right? Like Java Swing is huge in the enterprise. We have some obvious, very close to home examples of where there's a shared UI and that worked out. But I would consider that more of a notable exception than like the rule of how things get done. And especially on mobile, it hasn't gone well so far. And shared architecture on the web is going to be more difficult, right? I think that as time goes on, as these frameworks develop, logic and architecture in all these contexts will be more easily shared, especially as WebAssembly comes around with threads. These things at an architectural level can start looking the same, but the web is a lot more difficult because the standards decisions made by various orgs at different times. There's no SQL. I kind of rant about this often. Like, it was essentially one person at Mozilla who just decided they didn't like SQL, and then we don't get to have it. So I think the long view, and this could be totally naive, but as an industry, we should really be kind of pushing back on as mobile applications are delivered more on web, we should revisit some of these standards decisions. I know people are. I just want SQL back, let's just figure that out. Anyway, great. So that's not what we're talking about. We're talking about mobile, native mobile only, and native mobile only is much simpler. For all their differences, Android and iOS architecturally are very, very similar under the hood, right? With some library abstractions, it's pretty straightforward to write shared architectural code. This is my experience from J2OBJC. I mean, some of this stuff was super straightforward. You have threads, files, networking, SQL. They're both Unixy. They're actually very much the same under the hood, right? So we have a couple of example apps you can use now. If you weren't aware, iOS development with Kotlin Native and Kotlin Multiplatform is still what you call new. So there's not a ton of stuff out there. I'm going to show you what you can realistically play with now. So we got Droidcon with Kotlin Multiplatform. Conference apps are great because they're like a funky testbed. You can do funky, weird code stuff, and people don't get too upset if it's a little crashy, In fact, fun fact, our first Kotlin commit was in the middle of 2014 on the original Droidcon app for our first Droidcon year. It was a little funky then for Android. We ran into some issues. So this year we're publishing for Droidcon NYC, which just happened, and for Droidcon SF, which is happening in November. If anybody is super interested in playing around with some of this stuff in a live context, it's open source, so reach out. We're definitely going to have some things to work on. There's also a KotlinConf fork, because KotlinConf also uses Sessionize, so you could have done KotlinConf app with our code, but don't do that because that's not nice and they have an official app. Anyway, architecturally, so at the top, you're going to get your completed screens. At the bottom, you've got your database. That KNArch thing I'm going to talk about in a minute. It uses Sqldelight as its primary interface to the database. And then there's some logic. There's some presenter kind of stuff, and then we use as a reactive architecture live data, and the live data registers and listens to the database, and that ultimately winds up powering your UI. And then a few things use this library called Multiplatform Settings, which is essentially shared preferences if you're an Android developer, but more than that. So I made a decision not to get super code heavy, because there's plenty of videos and stuff that you can go check out, but there's a little bit of code here. Essentially, the way the live data pipeline works in this is kind of how you expect a basic reactive model to work. We get a query object from Sqldelight, and then we pass it into a live data object. And then on the fragment side, we just observe that thing. And when the data refreshes, it calls this data refresh method with the data that gets refreshed, which is essentially just the session information for that talk. And then on the iOS side, one of the things you have to keep in mind is like practical current state of affairs. The Swift side doesn't handle the generics. They don't really make it through to the top, which I think is something that's going to be addressed in the future, but right now it doesn't. So to make life easy, we sort of harden or realize the types in a little bit of glue code. So in this case, this method is taking in a lambda that accepts a session info object as an argument, and then we observe it here, and then what happens is on the Swift side, that gets piped in. So essentially, we register for changes to this method, and the session info object gets pushed in there. You'll notice it's not a lambda format because I'm not as good as Swift, so I felt more comfortable with just the function syntax. But you could absolutely pass it in as like a lambda form for Swift. So that's all there is, except for all the other nauseating detail. I have a much longer video about how to do that, and that's the repo. I'm sharing slides out too, so don't worry about that too much. I'm going to update that a lot because there's been a lot in change how everything gets built. Our plan is to update this over time. I also updated to 0.93, which was really exciting until we got to the conference, and now there's like beta or whatever, so not as exciting. But that'll get updated, and our plan is to continue to update this app as a good example of like current best practices of architecture, at least through like the next year as things get updated in the ecosystem. So KotlinConf with Kotlin Multiplatform, obviously, is what they did. A quick walkthrough of this. I didn't spend as much time playing with this app, but it's another live example, also a conference example, and it is kind of ironically funny that those are the only two examples, but anyway. Settings are stored locally. It's just JSON blobs, so no databases, not to judge. Data is pushed to the server with KTOR on both ends, so there's a KTOR client, which we're not using, but we need to integrate soon. The data repository manages the data storage and also uses coroutines, which is why I have the dashed lines, clearly, for funky threading stuff. And then there is a presenter, which kind of does the logic. And by the way, I'm just showing one stack. This obviously isn't representing the whole app. So this is just the session detail screen. And there's a session details view interface, which is implemented by the individual platforms. This is sort of like how do you deal with the UI? A pattern I just call view contract, which essentially is you create an interface that has some contract with the front ends that gets implemented on the front ends. We do the same thing in the Droidcon app. It's a little more coarse-grained. They're a little more fine-grained, but anyway, you'll see. Okay, so yeah, here's the interface that's defined in the shared code. And then on the Android side, we have the update view, which gets essentially the data and whether or not you favorited this, and you do your front-end stuff on Android. And then on Swift, it's essentially the same thing. You just implement that method, you get the session model, you do what you normally do in the view controller. So, not to be that guy, but as a conference organizer who's been building conference apps forever, conference Wi-Fi isn't always great, and if you turn off your data connection, this app stops working. So everybody's a critic. Anyway, otherwise it's really good. So go there, get that, it's a good example. So in a very quick description of how you actually share code for Android and iOS, there have been a number of tutorials about how to do multi-platform, so I won't get too crazy about it. But essentially, there's a common module, and it's going to be standard libkotlin, minus the stuff you normally expect from the JVM, assuming you're a JVM developer. So there's no file, there's no date, a whole bunch of stuff. Common code by itself has a lot of logical classes, but it's pretty unaware of the outside world. So it like lives in a world where there may or may not be threads. You may be in a phone or an embedded device or a server or wherever. It doesn't know. So Kotlin, instead of like trying to put all these empty interfaces into the central thing, decided to go pretty lean, and you have to define that yourself. So you need a mechanism. Let's say you wanted to find out if you're in the main thread. There's nothing about threading in the standard Kotlin lib. So you need to do, say that your code expects to have a value that is going to tell you whether or not you're in the main thread. So you do this expect thing. You probably heard expect actual at some point along the way. It just says, I expect this value to be defined when I get there. And on the Android side, you're essentially going to find out if the looper is, your looper, and that's going to be the value of that. On the iOS side, there's a method that you call for that, which is pretty straightforward. It's going to return a Boolean. And just for completeness, if you were doing JavaScript, it would look like that, because there's only one thread, right? Unless you're doing some work or stuff, I don't know, whatever. But let's say that's how that's going to look. And as development goes on, you can define functions. I found it easy to, I need something. You just define the expect function, and you go in and use it, and then implement on your different things. And I just had one file that collected all of them. Background task stuff, freezing, which I won't talk too much about, a little bit of simple networking, yada, yada, yada. And then you can also do classes, which is going to be very critical if you're doing anything significant. There's no dates, as mentioned, in the common stuff. So I have a super minimal date and then some date format stuff. On Java, it does Java util date and the simple date format to implement those things. On iOS, it does something very, very similar, but I'll spare you. Another way you can do shared or platform-defined logic is to define lambdas and pass them in from your specific platform. So in this case, the first one is going to be like a static file loader. So in the Droidcon app, we use it to load seed data from assets or from the bundle, depending on which platform you're on. So in Android, we just call this thing, and then that method somewhere in there, load asset, just goes and loads from the assets folder. It's pretty straightforward. In iOS, same thing. We just load it from a bundle, and that's how you essentially get common code. You could totally do this with interop, and there's ways to do it with Swift and interop, but this is way easier for certain things, especially in the Swift land if you're just doing a couple of functions, so something to keep in mind. So back to common. Great. You get your common stuff. You're doing some of your specific stuff. You have to go and then define a JVM and a native side, especially if you need to define anything specific for those platforms. And then on iOS, that renders down to an Xcode framework. In your Xcode framework, you can consume it from Objective-C or Swift, just like it's another other framework that you've had, right? On Android, it's even easier. It's just like you're pointing at another Java dependency, which is exactly what it is. One of the things, and I don't get too deep into the whys here of this, but that's very different about this, which is why we liked Doppel too, is that code sharing is optional, meaning you don't have to adopt this big platform and make these big decisions. And it's native to the platforms you're working on, so you don't have this big barrier between what you're calling, right? You can start incrementally. You can do a little bit and then move up. You can write fully native when that's simpler or totally required. And you're not locked into this alternative ecosystem, at least as much. Not to call out, but like Xamarin or whatever, right? That's a much harder thing to adopt and a much bigger decision, which is much more risky. So back on here, libraries, of course, exist if you want to use other libraries. Essentially, you're depending on the common depends on a common artifact. The other two depend on their respective artifacts. Yeah, I won't get too into that. There's going to be a flood of tutorials and samples coming out over the next few weeks now that the tooling is kind of ready, so keep an eye out. So for iOS developers, some info that you should keep in mind, because it's going to be different in some cases, right? There's reference counting, but it's not the reference counting system you're used to. It works roughly the same, but it's not interacting with that normal one. You should almost never even be aware of the reference counting system, because it all kind of works differently. If you watch the keynote, if you watched the talk I pointed to yesterday, which you totally should have come to if you follow my Twitter, which you probably don't, but yeah, it should almost never run into a problem there. There's no reference cycles, which is you don't have to worry about weak and all that kind of stuff that you would in Swift or Objective-C. I am quite sure that this is going to generate concerns about performance out in the wild, so I would highly suggest to the JetBrains team or to an enterprising member of the community, if you wanted to have a blog post that people will absolutely read, explain why that isn't going to be a performance problem, cool. But I believe the JetBrains people. You can call this from Swift, obviously, but there are some complaints. I am by no means a Swift expert. But I've heard some issues perhaps about enums, generics. During the talk yesterday for Sqldelight, there was concern about struct types. There's concerns, but there's not really what I would call huge showstoppers. And obviously, over time, the situation is going to improve. I know that there's some ways of putting generic information into the generated header files. But we'll see how it goes. But again, selling iOS devs is going to be a big deal in a lot of places that want to adopt this, and certainly getting community support, at least portions of it. And if you give very easy things to point to say why this is going to be bad, then you don't get community support. Speaking of, there's no Bitcode support yet, but this is on the radar, and I know the Rust community has sorted this out. As far as I know, it's not really like a technical, serious problem as much as there's 2 versions of LLVM, and it's just not worth the effort to keep both up to date while they're working on the platform. So it's coming. Threading is super, super different. And that's for Android and iOS developers. This is kind of out of scope. It was mentioned during the keynote about sane concurrency. I can't stress enough how much you need to understand this to get really developing. I think there's a lot of expectation in the community that I'll just take my Kotlin code and make some common, and then I'll make a native, and then I'm an iOS developer. That is not how that shit's going to go. I curse occasionally to highlight things. It just isn't. Not that it's terrible, but if you don't understand it, you're going to be in serious trouble. So this is the talk I said you needed to go to yesterday. I hope you didn't miss it. If you did catch the video, I brought some people, and they were kind of, their eyes glazed over. It's a bit much to watch without any background. So I would spend like a week digging through the samples and reading this, and then go watch that, because it explains it in deeper detail. I have this series of blog posts in which I only have one, and I'm super overdue for another one. Which tries to explain how threading works in Kotlin native. And I'm committing here officially to have an episode 2 sometime in the next couple weeks explaining freezing and state and where things are at in the 0.9x world. Yeah, I'm totally going to do that, I promise. We'll see. And obviously during the keynote, there was some suggestion of what's coming down the road, even like language level recognition of these things, which would be super interesting. I know that there's some of that, like if you've ever played around with Rust, things like that. There's like modern thoughts around concurrency, which would be, I think they're kind of doing some of that at the runtime. To have it in a language compiling itself would be really kind of cool, but that's going to be a while. So IDE tools and Gradle plugins. Yeah, I had to leave some slides unfinished because the conference was going to change anything I put there, so I didn't bother. Here is the slightly updated. So the Multiplatform IDE, Intellij Community Android Studio. I was very surprised. I was expecting this to be a paid thing, and I'm really excited that it's not. And I asked them about this. There's maybe going to be some other stuff in the future that's like more around serious debugging or whatever. That's part of their licensing tier. We'll see. But it's going to be great news for adoption, and really looking forward to that. The Multiplatform Gradle. This plugin's super new, and it looks like it's going to be really cool. However, all this stuff kind of came out in the last few weeks. So my project's not updated yet. I'm going to do that in the next, hopefully this weekend or over the next coming week or so. It kind of killed a solid week of time while I was trying to update all of my dependencies and everything, but I think it's smoothed out, so we'll see how it goes. And then other Gradle plugins. There have been 2 other Gradle plugins related to native and multi-platform. I am still not super clear about what their plans are for that in the future, but hopefully that gets cleared up. So we're going to do a super quick walkthrough of all the libraries that are currently doing anything with multi-platform and native that I'm super aware of. And the first one, most importantly, is the standard lib, which is not really a library per se. But this is something you really have to understand if you're from the JVM world, because there's going to be, again, a bunch of stuff you're not used to missing that isn't there. It's not the end of the world. It's actually pretty elegant once you get into it, what they decided to include and what they didn't. But you have to absolutely understand that. There was a talk yesterday that also was on my should go-to list, and if you didn't, you can check out that video. It wasn't specifically multi-platform, but it was standard lib, so hopefully it would be useful. The Kotlin native runtime, again, it's not a library. You don't need to know this like at the super deep level. Like first thing I tried to build involved something that was coming from JNI, so I did have to understand this at a bottom level. But there are definitely things that you should understand where they are and how they work, and it's open source, so it's a good way to do it. Check out the freezing thing. Check out the annotations, which are related to state. Check out worker-ish. Worker right now, I think as coroutines come out for this as a prominent thing, I don't know how much worker is going to be used with the average developer, but we shall see. Also, if you build the source from source, you get this little secret thing that I've been using that shows you all the platform libs that get import from the native platform, so you can look at the Kotlin. Now with the source completion, you lucky folks that you get that now. We've been doing work without that, essentially working in the equivalent of Notepad for the last 4 months. So this isn't going to be as useful, but it's still cool to look at. KTOR. So if you're going to be doing networking stuff in the near future, this is probably what you're going to be doing. This was not super ready in the dependency world, so I'm still just getting my feet wet. But we're converting our apps to KTOR in the next couple of weeks. I'm also really excited about the server stuff because it's using coroutines on both ends, should be really performant and really cool. And here's a talk that's coming up at 1 o'clock, which we'll talk about the back end at least, so you might want to check that out. Serialization. And again, a little light on using this because the serializing part wasn't ready for native until like a couple weeks ago, not even. But it has this plain old JSON parser which allowed any app development at all to happen at least. And serialization is ready now. It's using a compiler plugin, and it's really cool. So it's like JSON and sort of like Wire and whatever apps power CBOR, whatever that is. Other people seem aware of CBOR. I'd never heard of it. Anyway, it's kind of all that rolled into one, and you're definitely going to be using it, and it's connected into KTOR, so it's pretty cool. Kotlin X coroutines. Again, I'm a little late to the coroutines party because all I've been doing is native for a long time, and the coroutines weren't really ready. But now that I've had some chances to really think about it, this is super amazing tech. If you haven't been paying attention, you should start very soon. Unfortunately, I've been watching this thing every morning for the last several months. Multi-threaded coroutines and Kotlin X coroutines are not ready. And I told him I was calling him out, so I'm calling him out, because it said a couple of weeks, a couple of months ago. I didn't get a hard date, because nobody gives you hard dates on anything, so my completely uncorroborated, unsubstantiated, JetBrains did not tell me this directly, is probably January. But who knows? He didn't tell me that. Somebody else told me. Just being clear. OK, so KNArch.DB. It's pronounced narc. And I'm going to have a new name because nobody pronounces it narc. I thought I was being clever with my naming. I built this. So it is a port of AOSP's Sqldelight Java stack and the C++ stack that was JNI, and now it's whatever Kotlin native does. And the CTS test suite, the relevant parts to make sure that everything works properly. And it's a multi-platform definition, but I'll spare you the screenshots, which aren't very helpful. We use this for database access with an API that's quite similar to what you would be used to on Android if you're an Android developer. The idea would be to help foster the development of other libraries to do multi-platform database development. And future changes. So I had to serialize all this stuff because multi-threaded things are really difficult, and there's a ton of Java-style multi-threading inside there. Don't worry, that's how Android worked with databases up until about Gingerbread, so it's not going to be a huge performance issue unless you're doing a ton of multi-threaded reads. That's something to be going back to. Possibly a coroutines-aware API, if that makes sense. That's something to look at. Philosophically, I just copied this from AOSP, thinking that there was probably a lot of collective wisdom built into the code. But as time's gone on and really thinking about how one might use it, I don't know about some constructs like cursor window, yada, yada. So that's going to get a review. We're going to talk to all the folks and just a bunch of other stuff that maybe should get touched up. And yeah, Sqldelight, Multiplatform Delight. It was also on the you should have gone to that talk list. But this one was live streamed, so you should be able to check it out. It is, essentially, you write your SQL, and then that generates your code, instead of the other way around, where a lot of database libraries, you write your code, and it helps you interact with SQL. When this was the Java version, I found it confusing with the auto value and the factories and all that stuff. The Kotlin version is, to me, very much super straightforward. And it allows you to do things that a lot of libraries don't allow you to do, right? So in the Droidcon app, we have a relatively complex query. So on the list of sessions, we want to list all the people, all the sessions, and then for each session, we want to have a comma-separated list of the speakers. And if I just give this to like a junior developer, no offense to junior developers, I think they would have like queried the thing and then for each row gone back to the database and built the thing in code, which is garbage. That's pretty hard to do out of the box with other libraries for databases. But here, I just made a left join with a concat, which did it very easily in SQL. And then Sqldelight just gives you this nice little string field, which was super useful, right? When I first started using it, though, I got a little crazy, and like everything became a custom query, which meant you had a bunch of custom objects that looked a lot alike, but they didn't have the like types. So it was very hard to create common code. And then this is way out of scope for this talk, but I had this idea of using coroutines to put the RBAC and ORM by allowing you to grab related tables without having to create the mess inside of the framework itself, and also without locking up the main thread. So that's a to be discussed, maybe, unless everyone thinks it sucks. But I spent a lot of time doing ORM. I did the port of ORM Lite for Android, by the way. So either you're welcome or I'm sorry, depending on how you look at it. That's how far back I go. So anyway, yeah. And if you're using Sqldelight today, you're going to be probably using KNArch.DB underneath it. Again, I do think that there's some optimization with how KNArch.DB works. So that's a TBD, but baby steps. KNArch.threads, again, probably needs a different name, but it doesn't matter because it's temporary and it's going to go away soon. I built this because there was nothing to do a lot of the threading stuff you would normally be used to in your mobile app development world. So there's atomic support, which has already been deprecated because that's now, I put it in atomic foo. There's a thread local thing, which is actually pretty useful in a couple cases. And then I took Google's live data and I implemented that on iOS and multi-platform. So we have a reactive component in the multi-platform, which we otherwise would not have. Yes, it does a lot of stuff in the main thread. Yes, it doesn't do a lot of things you'd want to do. No, I probably wouldn't pick to do it on Android, no offense, but here we are, because it's like 5 classes versus like 1,000 for RX. So it was a much easier implementation. Again, familiar face. There's a long chat about cold streams and reactive architectures, and I have it on pretty good authority that JetBrains is going to be publishing something along those lines. So my live data thing will probably go away. But then again, people seem to like live data, and that it came about in the world of RX, so who knows? Maybe somebody wants something that's like that, that's simpler, but we'll see. This is going to be after the coroutines thing, I assume, if ever. So I don't know, March. I mean, I'm just throwing out dates. I'm making it up. Don't listen to me. One thing while I got you here, the people on the team, there's a multi-platform bug, a type alias thing, where you can't type alias Java protected things, and it was a super painful bug, and it's been open for a while. So please, 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 please fix it. It created hell on a couple things I tried to do. So multi-platform settings, really shared preferences. This is Russell Wolf, and it provides an API between shared preferences in Android and its user defaults in iOS. It's for like single value item store. Essentially, if you use shared preferences in Android, this is that, but across the platforms. The API is quite straightforward to look at. It's a little old, but you know what I'm saying. Anyway, Timber, Jake Wharton's well-known Android library had got the multi-platform treatment, but not on the native. I forked and did what I would call the first draft on native, so you can use this today, but I would expect something more formal coming out of the Jake world sometime after KotlinConf. Atomic foo. This is the JetBrains library. Native compiles, but native wasn't implemented to actually do the atomic stuff unless there's a fork I didn't see or a branch or whatever. So I also published a first draft that allows you to use atomic foo. We're using that in Droidcon. Kotlin XIO. I will be perfectly honest, and I don't really know much about it in detail, other than it is a multi-platform I/O library that is coroutines enabled that should be very performant and empowering a lot of the things that they do. So I think it's really good. I don't know much about it, so I'm not going to talk about it. However, I like when people announce things at conferences. So at Droidcon, they announced OKIO2 multi-platform, and I'm going to spare you my horrible fuzzy camera work by going to this slide. It's multi-platform, but not like complete yet on the native, and There's plans to do coroutines later, so it's kind of like it's getting there. And but I was wondering, like, how does JetBrains think? Like, oh, there's going to be these two I/O libraries. At first, we were like, well, they're not really doing it the same way or the same thing, but they also were pretty excited about it, and I kind of get why, because people have been asking me since I've been working on this, like, is this really going to be a thing? Is this like really going to happen, this multi-platform? We hear all this crap, about sharing code and going cross-platform. Yeah, it is. Yes, this should be an indicator that it is, and yes, it's coming soon. That's kind of the way I read this. So this is different. This is a different thing. This is not sharing JavaScript code through a web browser. This is an entirely different way of doing it. So keep that in mind. All right, my wish list. Stable Gradle plugins. I know you're busy, but like, oh my God. Like, I can't stress enough, there's been 3 entirely different DSLs in the time that I've been working on native, and I assume this is stable now, or it's going to become in the very near future. And I know that things take work, but it would be great if we just said, okay, this is the last one, and we're going to iterate on this one. Also, a very specific task to me, I use C++ in a weird way because I'm using it like JNI with their internal runtime stuff. I asked the native team about that yesterday, and they were just confused. Like, why would you do that? And I'm like, well, I don't know. But please put that in there. Significant library examples. This is the other thing, too. Like, there were some examples, but they would have, like, one method, and then they didn't try to publish anything. Leading up to KotlinConf, everyone that was working on these libraries was trying to publish them in the new plugin, and we all lost, like, huge chunks of time. I know this is all stuff that's going to get solved very soon, but please, get on it. The only thing I really care about, and if I got anything for Christmas, would be multi-threaded native coroutines. I can't stress that enough, and it's going to be super critical for the next sort of phase of libraries and adoption coming out, I think. And a reactive library, already discussed. I know this one isn't probably going to happen, but being able to step into debugging and look at the Kotlin code in Xcode while you're running stuff would be super useful. J2OBJC had a way of doing this by outputting line directives. I don't know if there's a way to stuff what the output of line directives would be into the thing, and it doesn't really jive if you're trying to sell licenses to other tools, but it'd be cool. All right, community wish list. I put out a call for people to tell me what apps or libraries they super desperately needed, and most of the responses I got were like lists of popular Android libraries, which is not really what I was asking for. So I don't know how good this list is. The first one's very important, though. A mocking library. There is mockk, M-O-C-K-K. There is a pull request that's attempting to put this in there, but it's not complete. And it's extremely difficult because using a compiler plugin in native and writing out native output IR code. However, if you wanted to own something in this space as an open source contributor, this thing would be amazing, and I think people would love you for it. So it's not going to be easy, but take a look at that. Dependency injection, I know that there's several flavors of service locators, and there's some kind of online argument going on these days about that. I don't get into it, but one of them for native would be good. It's trickier than you think. Again, go back and look at the state thing. Build instrumentation, this is the slide that needs to get updated because we're hearing all about compiler plugins, and they're going to be part of the thing soon, and you can do one right now if you really feel like you need to. So that's how you're going to do that. And date support, there's no date stuff. We already talked about that, be good. UI stuff, and this is kind of my plug for what I'm going to try to do over the next several months. Not make shared UI, I want to be clear about that. But there's a lot further into the UI space you can get, and I want to see how that's going to jive with the current trend now of unidirectional data flow, React-like solutions that are going on in the native world. Not all of the native world, I know, but a bunch of people are looking at this. So as I have no real day job anymore, I'm going to be in SF for a couple weeks in November. If anybody wants to just sit down and talk about that and kind of traveling around and doing that stuff. And yeah, that's what I'm going to try to do. So if you want to get started, I'm assuming familiarity with Kotlin. If not, go get the cones, and you're going to need to know Kotlin. Build samples. Obviously, conference apps. Going to be several others in the very near future because now the tools are out. Now things are kind of working. I would expect a lot of people to jump on board. Go check those out. Kotlin native docs. Again, I can't stress enough. Dread. I put those words together. learn threads and state. It's going to be super, super critical for anything you're going to do. There isn't a lot of docs around that, but it's going to be changing soon, so check that out. And if you wanted to do a library, I would actually start with Multiplatform Settings, because it's a pretty straightforward library of relatively limited scope, and the Gradle config is like not super custom. Like as projects get older, projects will be done by people who do open source projects all the time. They have a lot of copy paste of their own style of Gradle, which is really hard to follow. After Timber gets updated, that's also a pretty straightforward library that I would look at, and then look at the rest. Like the KNArch thing is crazy. Don't try to look at that. And join the Kotlin Slack, which is super critical. There's a lot of help, and there's currently a lot of direct access to the team engineers, which will change as it grows. So now is the time. And now is the time also, if you ever wanted to really get involved in open source and have something that's going to be impactful, it is early. So a lot of people will use the things you build. And I can't stress that enough. So when is it going to be ready to make iOS apps? Well, I published an iOS app, so it's ready now-ish. It is definitely a little difficult, right? Tooling is going to go a long way to make that happen. So, we'll see how it goes. I made a prediction about 6 weeks ago about what was going to happen at KotlinConf, and I was not entirely wrong, but a little off. We didn't get the coroutines yet, per se. Well, multi-threaded. There are single-threaded coroutines. I'm picturing somewhere around there. And I would say somewhere around there also, there's going to be concurrent library development going on. And early 2019, you should be totally capable of making some pretty straightforward apps. Middle of next year, this is mainstream. I'm not going to say that it's adopted everywhere, but you can absolutely be doing production level stuff. That is my guess. Here's attribution for the images. They all had appropriate licensing as far as I'm aware. And that's me. Also a little bit of an announcement. I finally convinced the team that it's worthwhile for me to hire a Kotlin Multiplatform specific person besides just me, and cross our fingers that we also turn up clients in the near future too. So we're out looking for this, and for the next month or two, it's just going to be working on libraries, but we'll see how it goes. That's it. Questions? Yes? That's a great question. No, it is, okay, so I have to give you a better answer to that, because, I did, there was locally, and you could see at least the stack trace itself and the method names and stuff like that. It doesn't really give you a good line number indicator, which is unfortunate. So sometimes you're doing the old style of logging some stuff out. Not great. On Crashlytics, it actually did a pretty good job reporting what was happening out in the wild. That is definitely something that I'm going to have to. This is why I got really spoiled in the JTOBJC world, because it would take you to a line directly in the Java file when you got a crash. So workable, not great. Right there?
Yeah, I've got two apps, one on iOS and one on Android, both a couple 100,000 lines of code, and they obviously have a bunch of shared logic. Is multi-platform for me? Is there a way that I can extract some pieces of logic? I'm not starting from scratch, but with two already published production code bases, extract some of the shared logic into some Kotlin module.
Is your Android app Kotlin?
Yeah. Well, it's halfway there.
I mean, that's the use case, really. I mean, that's what should be really straightforward to do, is start pulling out common logic, especially if it's just logic. That's super straightforward. And then what you do is you wrap that up, and on the native side, you're essentially giving iOS a framework, and it just thinks it's Objective-C. So it would be really straightforward for me to do it. You got to get into the docs, but it's the use case is essentially that, and that's one of the benefits of it. So that's what we're going around pitching to people, orgs that want to do a little better with their efficiencies. So yeah.
So if we do have that in a Git world where we've already got two GitHub repositories for iOS and Android, I'm trying to imagine what this third project is going to be. Does it have to be bundled with the iOS in order to pull it in as a framework, or is this a Gradle thing that gets published out to a Maven repo, or?
That's another Gee, great question. I don't know. I haven't thought about it from that perspective. How you package it in Git is like, I'm not entirely sure how you would do that. You know, I'm sure someone's going to say do a Git sub module or whatever, which I would say I hate them, so
I've
don't
struggled with those.
Yeah. That I don't know. I mean, that's more of just a dev organization question. I would say I had a best practices thing I took out of here. Absolutely don't, like if you have multiple devs or teams, don't treat it like you're going to deliver a finished product to the iOS team. Like they absolutely need to be able to edit the code and build it because you're always going to be missing some piece of data. You don't want to wait, for the next sprint for the upstream people to do it. How you package it, I don't know. I could guess, but you know what I mean? That's a to be decided kind of thing.
How do you predict the future will look for multi-platform with things like this, Flutter, React Native? Do you see any of them dominating?
So another slide I took out of here is I can't predict the future. If I could, I would be streaming from my private island. So I don't know, but this is why we like this is it's very low risk, and it's a very popular thing in the community. And it's very easy to integrate with the native platforms themselves. And Flutter, I think, is fairly high risk because you have to adopt a lot of changes. I don't know how Google is going to be, I don't know how seriously concerned they are going to be with your iOS experience in 5 years. You know what I mean? Like, there's more of a risk going on there. And React Native is React Native. Like, some people love it. Some people super, super don't. So I don't know. I think that this, though, is you can integrate it with existing projects without really changing a lot about how that works. There's no big decisions, so it's lower risk. So I think it's going to be very successful, but we'll see. I just shut down a project that I thought was going to be successful, so what do I know, right? But anyway.
Okay, thank you. Do you expect any pushback from the iOS crowd and from Apple? And what do iOS developers think about multi-platform? What's their reaction when you propose such changes?
Well, if you remember the really angry dog slide, yeah, like I absolutely expect iOS teams to not universally be super jazzed about this. But that is a lot of how developers react. Like people, not to get into psychology, but you attach your identity to the platform you're on. You attach the identity to the community you're in. So there is a point at which the arguments against something leave sort of the rational and just go into the I don't like this thing, but that's masked in an argument. So a part of it is just taking out things that you can shoot it down with, like hey, there's no generics. There's none of this. That just sucks. I can't use it. We're just going to stick with Swift. Like you got to start knocking those down. Is every conversation going to go okay? No. Is it going to be a lot better than trying to pitch a Java to Objective-C thing? Like, yeah. So it's going to be somewhere in the middle, I would think. Apple, Apple approved our app. They didn't even push back on it. I mean, there's React Native. They let React Native update code dynamically. So I wouldn't say Apple is super, super against this stuff. I think that they trust that their native apps are the best user experience, so they're not too worried about other people's stuff. That would be my guess. And the other thing is like J2OBJC, if you have an iPhone, it's more likely you have a J2OBJC thing on your phone than anything else because it's in Gmail and Google Maps and Sheets, maybe not Google Maps, but it's in a ton of stuff. So Apple's kind of, yeah, they could kill it, but they could kill everything. Who knows?
Coroutines being ready for native soon, why do we still need to be so aware of the threading model of Kotlin native?
So Coroutines not ready for native? Yeah. Because your data, like if you're going to share a chunk of data around the threads, so like in my case, I have the database access module, and I have that available to other threads. That all has to be frozen, and you have to understand how to do that, because if you don't, you can't give that to other threads. So even if you're in a coroutines model, if you're going to be in other threads, especially if you don't know the context you're going to be in, then the data objects you're passing around have to be multi-threaded capable, which means frozen. So you at least have to understand that. But the thing I had in the slide where like you can maybe look at worker, maybe not. If you're in coroutines, you probably never use a worker. So some of it you definitely have to understand, like state. State's super important. The rest you probably won't.
And so in your diagram, you showed us that the code to access the database, the repository, the network is a common code, but the native concurrency model is a native issue. So do you have this then on the native layer?
Can you give him the mic? I didn't get enough of that.
So in the diagram, in the architecture diagram you showed, we could see that all the coroutines, the access to the repository is in your common module, but the native concurrency model is a native concern. So on which layer do you then implement this frozen mechanism or use them?
Yeah. So in my app, I made a expect actual method called go freeze, and on Android it did nothing. Okay. And what they do in the KotlinConf app, they just pass in a coroutines context object, and they pass it into the initialization. So it keeps that in the centralized code, but in the native code, it's just saying use the main thread essentially, and in the Android code, it's saying use something else. So it's actually that stuff's really straightforward.
Cool. Thanks.
All right. Thanks for coming out.